4. Chapter 4, the title is Anti-Differentiation. Anti-differentiation, a big word. Okay, what does this mean? What is it used for, and why do we need it? Okay. So first, let's review a couple of things. When we have a function that is the distance function, can anyone tell us why we determine the derivative? Who cares? I have the distance function. It's a function. And we looked, so far, we looked at f prime. What does this mean? Why do we even want to look at f prime? What does it represent? If this function is the distance, f prime represents
change
of, yes, of,
is it the change
of distance,
change of distance
with respect to
x
with respect
or
to
with,
time.
with respect to time. with respect to
Exactly.
time.
So this will be the rate of change of distance with respect to time. Also called, it has another name. This is the long name, but it's also called anyone?
The derivative.
Yes, the derivative also, yes.
The slopes.
Yes, the slope, it gives the slope of the tangent line to the graph of this at any point also, yes, also. Slope of tangent lines to the graph of f of x, but also in one word, this is called, in one word, all of that, everything is correct. But in one word, we say this is?
Is it dy over dx?
Of course. And in one word, English word, it's called, if this is the distance, this is called
The speed.
yes, thank you very much. It is the speed or velocity. So in the past, if the distance function, give me any function, anything you want, with natural log, with exponential, anything you want, polynomial, you choose.
3x squared plus 5x.
Okay, plus e to the x. Let's say this is the distance. Here is the velocity. What will the velocity be? Anyone?
60x plus 5 plus x e to the x.
That's it, because x prime is 1. That's it. Good. So now, coming back to this fancy word, what does this mean? Well, it means at this point, we are given f prime. We're asked to find f of x. So let's see how we undo the differentiation. We are canceling the differentiation. We are going backwards. So here we had the function. You gave me a function. We say, as an example, doesn't have to be, it can be anything, right? But let's say this is the distance. We differentiate it to find the velocity. or speed. Now, we do not have the distance function. We are not given the distance function. We are given the derivative. We are given the velocity. And they're asking us now, go back. Go back and find the function. Let's see how we do that. So, very simple with this piece, right? Which, I'm jumping to the third one. Which function differentiated would be e to the x?
Would it just be e to the x?
E to the x, indeed. Perfect. Backwards now, for 5. Which function prime will be 5? What should I have here? So that when I differentiate it, I get 5.
5x.
That's it. There is no other way. When I differentiate 5x, I get 5. Awesome. Plus, this is slightly more difficult, and we have to explain how we get to that. So here's the formula that we use. So if I want to get, I'm trying to differentiate, I'm trying to think what would be the best way to present this. So if I have x to n plus first power over n plus first power, and I differentiate this, I'm coming back to this, I didn't forget. I just want to explain something first. So I have x to a power, which is n plus 1, and I have the denominator, which is n plus 1. Let's just differentiate this for a moment. I will bring n plus 1 in front, but it will cancel with n plus 1. N plus 1 with n plus 1 will go away. And then what is the answer? X to which power? Anyone would like to help here?
Is it to the first power?
But I have n plus 1, right? So n plus 1 comes in front, it will be simplified, and I have to subtract 1 from n plus 1. If from n plus 1 I subtract 1, what am I left with?
Oh, n.
That's it. So look what happens here. In order to undo this process, all I have to do is copy the number that doesn't change and multiply by, increase the power by 1, and divide by that number. So what is the power of x here?
1.
1. So then I have to increase that power by 1 and divide by the result. So I have x to the second power over 2. When I simplify, I get 30 x squared. So the answer here is, to make sure this is very clear, very important, plus a constant c. What does this mean? It means that there are many, infinitely many functions whose derivative is this. Let's check. Bring down 2, simplify. With 60 x squared, yes, 30x squared, yes. And differentiate 5x, and I get this. Differentiate this, I get this. Differentiate the constant, what do I get?
Zero.
0. So this is basically a family of functions. All of them have the same derivative. To be exact, the formula here, this is correct, but I also have to add that c. So I'm going to write it correct now with a c, plus c. I'm going to write it again because it's too tight in there. for everyone to see, then this is the formula for the power rule. X to n plus first over n plus first plus a constant c prime is x to the nth power. What I would like to do now is practice a little bit. I'm going to share my screen and let's choose. I would like us to choose. Don't look at the symbol yet. I did not explain. In a minute or two, I will explain the symbol and we'll talk about it. But right now I want to focus on 47 through 56. Please choose any problem from here. We are given the derivative. We want to find the function. Which one would you like to start with?
54.
Let's start with 54. In 54, we have f prime of x equals 5e to 2x. And notice that we are given another piece of information, that f of 0 equals, they say, 7/4. Perfect. Okay, so I did not expect you to choose 54, so I have to explain. So this is not a polynomial function that we just discussed, but it's something else which we need to get to anyway. It doesn't matter. So we already know that e to the x plus a constant c prime will be, anyone?
Would it be e to the x?
E to the x indeed. E to the x prime is e to the x and c prime is 0. Awesome. Now, what happens if the power is not exactly x? It's a number times x. We have to make a small adjustment. E to 2x divided by 2 plus a constant c will be e to 2x. So if the number in front is 2, I need to divide by 2. If the number in front is 3, I have to divide by 3. If it's -5, I have to divide by -5. So let's check. E to 2x prime is e to 2x times 2. The 2's will go away, and I get e to 2x because c prime is e to 2x. Because c prime is 0, so then the answer is e to 2x. So then we are given f prime of x, which is 5e to 2x. Let's find f of x. 5 is the constant in front. Which function prime is e to 2x? It's right here. So this is e to 2x divided by 2. But I have to write plus a constant c. Because when I differentiate this, I will get this with any c. Now we are told that f of 0 equals 7/4. Why do you think this condition is given to us? Initial condition. Why do you think this is given to us? What are we doing with it? And why is it given? Well, it is given to us to find c. That's why it's given to us. Well, what happens if I find c? If I find c, a particular c, this is no longer a family of functions. It will be just one function that fulfills the given condition. So, f of 0 is 7/4. So 7/4 equals 5/2. When I plug in 0 here, how much is e to 0? E to 0 is anyone
Is
with
it 1?
Exactly. Plus a constant c. So this equation will give us c. I subtract 5/2. So c equals 7/4 minus 5/2. We multiply this by 2. 7 minus 10. c equals negative 3/4. So now, after this arithmetic calculation, we have a unique function this time. Unique function that fulfills this condition and has this derivative. And the unique function is, can anyone give us the unique function so we can write it? We have 5/2 e to 2x plus, I should write minus, 3/4. I'm going to erase that because it's negative. There is no need for me to put plus and then minus. So we just write directly negative. Good pick. Is this clear, everyone? Of course, we're going to look at other examples, but are these steps understood? Anyone? Give me a heads up, yes, no, anything.
Yes, that's good.
Okay, I'm going to share my screen again. Let's choose another. Can I choose?
Yes.
I will choose 51. 51, and this is on page 392, and I forgot to write that we chose this also on 392. Okay, perfect. So 51 is f prime of x equals 8x squared plus 4x minus 2, and we are also given f of 0 is 6. Fine. We're asked to find the unique function. For now, we're going to find the family of functions, and then we'll plug in this condition. So not yet. So I copy 8. Can anyone tell us which function prime will be x squared? And remember to use this formula.
It would be x squared over 2.
But 3, right? And we have to increase, yes, we have to increase by 1 and divide by the resulting number. Perfect, plus 4. Can anyone give us which function prime is x?
X squared over 2.
That's it. Minus. Which function prime is 2? Very good. Plus a constant c. Awesome. Now, only now I can look at this. And it says, when f of x is 6, x is 0. 0, 0, 0, c. That's it. So then the function is 8/3, x to the third, 4 over 2, 2, x squared, minus 2x, and plus 6. This is no longer a family of functions. This is a family of functions, but only one function fulfills this condition. And this is it. Okay, I would like now to look at a word problem, and then we'll come back to that symbol.